Good morning, everybody.
Good morning, sir.
Well, my name is Abhash Kumar, and I'm taking care of your physics. But here, what we are doing at this moment is we will be starting up with a fresh chapter, that is work and energy. And in work and energy, you have already read about work and energy in your previous classes. I would say, starting from class grade 6 to grade 8, you might have gone through all this stuff, which are important terms, which are important. I think you have gone through that particular thing. But today in class 9, work and energy plays a different role altogether, right? And they have some sort of numerical skills as well as analytical skills, and they give a different dimension to the entire approach of science as a whole. So I must say that work and energy plays a very vital role. So to start up with this particular chapter, we have got some very beautiful things by Class Edge, Tata Class Edge, and Tata Class Edge has provided us with lots of informations from the basic, from the grassroots level to the upgraded version, and from the exercise questions given in the NCERT book also. So they have helped us in various manner. Apart from this, they have given us some kind of, I must say, they have given some sort of videos, PPTs, with which that benefits, that brings some good things for a student to learn and understand this particular chapter. So work and energy as a whole is a beautiful chapter. You must enjoy this. Before that, you might have gone through some important chapters like motion, forces and laws of motion, then gravitation, and this is the fourth chapter for the discussion, that is work and energy. Now to look about this particular chapter, work and energy, we have got work to understand here. What is work? If I say work done, when do we say that work is done? हम कब कहते हैं कि हमने कुछ काम किया है? When we say that work is done. Now you see, whenever we apply some kind of force on an object, and if we get to see some kind of displacement in it, then we say that work has been done. Yes or no? Work? Yes? So if you see, if I take the whiteboard and let me explain you this particular part, work done is basically, work done is defined as force multiplied displacement. Force into displacement gives us an idea about work done. Yes? So this force into displacement is nothing but work done. If you look at the, if I show you something related with the picture, you can easily understand this fact. Let us suppose that this is an object of mass m, and if it is held up at a point A, it is placed at point A, when we apply some kind of force to it, now this force is definitely going to be an external force. There are definitely some internal forces which are intermolecular forces that exist inside an object, but we are not considering that part. What we are expecting here is there is an external force which is acting on the body, and the body is shifting from this particular point A to another point B and so on, and it continues to move on. So under the action of this external force, the object has displaced by a distance, say s, along the same direction in which the force is applied. So when force brings about a change in the position of an object, in the direction in which it is getting applied, then we call that thing as work done. We call this as work done. So mathematically, this is an expression for work done. Now whenever we do some kind of work, there is energy that comes into picture. Either the energy will be absorbed or the energy will be released, right? There are some various parameters where we need to understand this. Right? Is that clear? Now, work done, if you look at the mathematical expression, this work done, W is equal to F into S, force into displacement. What is the SI unit of displacement? What is the SI unit of displacement? What is the SI unit of displacement? Meters. What is the SI unit of force? Newton. What is the SI unit of force? What is the SI unit of displacement? So what is the final unit of work done? Newton meter. What is the SI unit? Newton meter. Newton meter is the SI unit of work done. Is that clear to everybody? This Newton meter has a name and it is also known as joules. What we call it? Joules. So 1 Newton meter of work done, 1 joule of work done is always equal to 1 Newton of force applied on an object and the object has displaced by 1 meter. So this defines 1 joule of work done. Is that clear? So when do we say that 1 joule of work has been done? 1 joule of work has been done when a force of 1 Newton makes an object to get displaced by 1 meter. So that is the definition of 1 joule of work done. I hope I am very clear at this particular point. Do you have any question to ask? No, you don't have any question as such, but I do have some good questions for you. Can you just say something about positive work done, negative work done and zero work done? When work done will be positive? I am giving you an example. Say for example, if I go with something, not with this, another kind of thing. Let me go with some whiteboard, basic whiteboard. There are various kinds of work done. You see, the first one is being positive work done. What is a positive work done? When work done will be positive? When work done will be positive? When the force applied in the same and the displacement happens along the same direction, then we can say that work done is positive. For example, you see, when you are kicking a football, what is happening to the object? The object goes with a greater speed, isn't it? Initially it was at rest, but when you kick the ball, it went with a greater speed, isn't it? So that kicking a ball is an example of positive work done, right? When you are sitting in the car and the car suddenly starts and moves and gets accelerated, then such a motion brings about one concept, that the work done by the object is positive because it is accelerating, it is gaining speed, isn't it? So that makes it positive work done, isn't it? But if I ask you what is negative work done, what will be your answer? When work done is negative? Work done is negative when the force and the displacement, they remains opposite to each other. And how will it happen? Say for example, you are sitting in a bus. And the bus is moving with a greater speed. Say for example, this bus is traveling with 100 km per hour. It is moving with 100 km per hour, and suddenly the driver applies brakes. So what happens to your body? You move front. The vehicle stops. The vehicle slows down. So slowing down or retarding a body, what it makes? It makes the work to be negative because it is happening. The force is applying, and what that force is doing? The force is bringing some kind of change in the body, which is reducing the speed of the body. Isn't it? So force and displacement both are not happening in the same direction. It is always happening in the opposite direction. Is that clear? Yes or no? Yes. If I try to push this wall, there is, the wall will also try to push me back, isn't it? But if, say for example, if I am taking it with if I am running with this particular table, and if somebody comes and stops it, holds it, then what happens to the body? It slows down, and later on it gets stopped. So that's the case of negative work done by the body. So there are some variations in the work done. So one thing is the positive work done, second one is the negative work done, and there are something also known as zero work done. What kind of work done? Zero work done. What is a zero work done? Say for example, if you throw an object, say I am throwing an object like this and it comes back to my hand. So what kind of work, what amount of work has been done by the object? Zero. Why do you say it, there is no movement, there is no work done? What is the answer? What makes you to say zero for this particular thing? Because there is no displacement. The object has gone to a certain height and it returned to the hand again. It came back to the same point from where it has originated. So that makes it a zero displacement. Zero displacement you can see here also. If I push the wall and if the wall does not gets moved or moves along the same direction in which the force is applied, then also we say that work done is zero. There is no work done. So I hope you understand that what are the different types of work done at this particular parameter. Am I clear to everybody? Is that clear to everybody? Right? What is a positive work done, what is a negative work done, and what is a zero work done? Now moving ahead, we have got some more things to discuss at this point. Now this is going to be another thing. Now let me take you to my class once again, and the next topic for the discussion after work done is definitely going to be the energy and potential energy, what is written over here. So let us talk about energy. What is energy? What is energy and how do we define energy? What is energy? What is energy? Energy, if somebody asks you what is energy, what will be your answer? Energy is the ability to do work. It is defined as the ability to do work. It is defined as the ability to do work. Now when we do some kind of energy, either the energy is released from our body or the other body absorbs the energy. Yes or no? So energy is the ability to do work. Yes or no? So whatever the SI unit of work we have got, the same SI unit remains, holds good for energy as well. It is same. So if we have got the SI unit of work as joules, similarly the SI unit of energy will also be joules. Yes or no?
Yes, sir.
Yes. Am I clear to everybody?
Yes, sir.
Now there are two types of energy basically that we need to understand. The first thing is potential energy and the second thing is kinetic energy. What is potential energy? What is potential energy? Potential energy. This book is resting on my hand. Right? What is potential energy? It is not even moving, but there are some stored energy inside this body and that makes it potential. What is potential energy? Position. Yes. The energy that an object is having or stored energy which is there because of its position, right, or rest. So how do we define it? We say that the amount of energy, it is the property of an object to remain either at rest, not either at rest, to remain at rest or to remain at a position, and the amount of energy that is acquired by the object is said to be potential energy. For example, water stored in a dam. What kind of example is that? Water stored in a dam. What kind of example is that? Potential or kinetic? Potential energy. And if water is flowing through a pipe, what kind of energy it is having? Yes, kinetic energy. So potential energy, the energy possessed in a body by virtue of its position or rest is called potential energy. Secondly, we have got kinetic energy. What is kinetic energy? You see, this word kinetic has come from a Greek letter called kinema. It has come from a Greek letter called kinema. And what is kinema means? Kinema means motion. What we call it? Motion. So what is kinetic energy? How will you define kinetic energy? The energy stored in an object by virtue of its motion. The energy stored in an object by virtue of its motion is called kinetic energy. The energy stored in an object by virtue of its motion is called kinetic energy. For example, a running man. A running man is having a kinetic energy, right? A running man is having a kinetic energy. Similarly, a man swimming in the pool, what kind of energy is he having? Kinetic energy. He is moving, right? Water flowing in the river is an example of kinetic energy. But if I say water present in a pond, what kind of energy will it have? Potential energy, because it is not flowing, it is resting at a point. Am I clear? So kinetic energy is the energy possessed in a body by virtue of its motion. By virtue of its motion. I think I am very clear with all these contents. Yes or no? Yes. Do you have any question to ask? So this is the basic structure of work and energy, and I do believe that progressively we will continue with the same, and we will try to understand this particular chapter in a bigger way, and we will also try to solve a few numerical given in the book, in the NCERT content, as well as with the Tata class as question banks. We will try to solve more number of questions, and we will see, we will take the help of this particular software, and we will try to make out things easier for you to understand and learn this particular chapter. I hope I am very clear to each one of you. Thanks for your patience and timing. Thank you so much, my dear students.